Welcome to physics class. How's your day? All right. I guess we'll just get going then. Today, hopefully you started already by watching the video and filling in the first 4 rules. Okay, so that's how you're supposed to start today's class. I've got them summarized up top here. So you have to watch the video. The video talks a lot about a lot of things we'll learn in this unit, as well as specifically today how to draw field lines. And so you would have seen the 4 rules. Rule 1, lines point in direction of a positive charge, that a positive charge would feel a force. Rule 2, more lines means stronger charge. Rule 3, lines must go from positive to negative objects. And Rule 4, lines must never cross. So I just want to be clear, what we're talking about is if there were charged objects. And so in this case, what we're looking at is 2 positively charged objects. So say that they're just hanging metal balls, because that happens all the time, where we got 2 big metal balls with a positive charge that are repelling each other because they're both similarly charged. That could happen. And what we're wanting to do is draw lines around them that represents the field that they're in. And so we're talking about fields, and fields, there's an area around an object where you would feel a charge. And so we're trying to represent that with lines. So if we're following these 4 rules, we've got to make every line represent the direction and magnitude that a positive charge would feel a force. And so this is incredibly important. What I'm highlighting, it's the positive charges would feel a force. And so that's what we're going to draw. A positive charge would be repelled by charge 1 and would also be repelled by charge 2. So how do we draw this then? We know that if a charge was on the left of charge 1, it would just be completely repelled in that direction. Similarly, on the right of charge 2, those will both act the same. If a charge were below charge 1, it would be repelled mostly by charge 1, but also by charge 2. And so we would see something like this. It would be repelled mostly by charge 1, but also by charge 2, and have it look like that. And we can draw a similar looking thing for charge 2, and actually similar on top for both of them as well. They'd be kind of symmetrical, and we can add more lines if we want, where it's mostly being repelled by charge 1 there, and mostly charge 2, but also a little curve because of charge 1. So that's not bad. Now, a charge on the right side of charge 1 would move away from charge 1, but also away from charge 2. But it wouldn't look like that, so I'll undo that. What is that going to look like? Well, it's going to look like this. Okay, right in the middle is where it's equally pushed down by charge 1 as it is by charge 2. And so what would happen here will be something like that. Okay, remember rule 4. These lines must never cross. And so if it was just slightly above, it would look like that and like that. And we can add a few more lines, and it's being repelled from charge 1 and charge 2 all the time. And that's good enough. Then we're done. And so what do these lines represent? These lines represent at any point what a positive charge would feel at that moment. And so we've got this nice curved line here. This means that if we would place a positively charged object right there, okay, let's just say that a red dot equals a positive charge. What direction would it feel a force? Well, what direction is the line going? The line is going that way at that moment. And so that is the direction that a positive charge will feel a force. And so if we put a positive charge right there, it would be directly in line with the line. If we put a positive charge right here, it would feel a force there. So we could put a positive charge anywhere, right there, and we know exactly the direction it would feel a force Now, obviously, it's not exact. We're approximating, but it's pretty close. There's a cool point right in the middle, right there, where it would just be stuck, right? It would feel an equal force this way and that way. This way being repelled by charge 1, that's this way, repelled by charge 1, and this way being repelled by charge 2, and it would just be stuck in limbo in the middle. But that's a very precise spot. Any change and it would move. Now, what does this mean? What if we put a negative charge? I'll do that in green. If we put a negative charge, which direction would a negative charge feel a force? Say we put a negative charge right here. It would feel a force opposite a positive charge. So you just go the opposite direction. So you could put that anywhere as well. Put it right there, and a negative charge would feel a force obviously towards. And not always towards charge 1. If it's here, it would feel the charge there. Slightly pulled by charge 1, but more so by charge 2, because proximity makes a difference. So there is why we're drawing these lines. It helps us to understand how different charges would feel forces at different locations around these two charges that are interacting. So let's move on to the second example. Here we've got two charges again. This time charge 1 is positive and charge 2, is negative, and actually double. It's negative 2, so it's twice as strong. So how's this going to look? We can start off by thinking lines always go from positive to negative, just like that. So you can expect that charges will want to repel from 1 and move to charge 2. Repel from 1 and then move towards charge 2. Repel from 1, but always be moving towards charge 2 as well, so it sucks it back down. Repel from 1, proximity is big, right? And so even here, repel from 1, but go towards 2. Obviously, on that side, it never gets the chance to turn to 2, but anything else, and it will come around. So I'd say that's good for charge 1, and charge 2 would have things coming in like this, straight away. I like to draw that one, and like that. Now we're not quite good to go yet, because we've got how many lines on the first charge? 1, 2, 3, 4, 5, 6, 7, 8. And on the second charge, we got 1, 2, 3, 4, 5, 6, 7, 8. So right now, these both look like they are equal in magnitude, but we know that the second charge is actually minus 2. And so if we look at our rules, rule number 2 says more lines equals stronger charge. So in this case, we see that this needs more lines than that one because it has a charge of minus 2 rather than just 1. And so because of this 2, we have to have double the lines compared to 1. So we've got 8 here, which means we need 16 here. So I would just start adding lines to how it will look. 1, 2. Do that, and I think I might have missed one. Not a huge deal. I want it to mostly just look like it's double. That's very clearly twice as strong as number 1. So that's just how you make it appear, and follow rule number 2, make them twice as strong. So that's it for number 2. Any questions? All right, then I'll just keep going. Last one. We've got 3 charges interacting here. Positive 2, we'll call that charge 1. A negative, we'll call that charge 2. And a positive 1, let's call that charge 3. This is twice as strong. This is number 1, so we'll have to do twice as many lines coming out of it. Reminder, lines always go from positive to negative. Now, these aren't going to be perfect, but I want to see you trying. So how do we try to make a line like this? Is this totally right if I see it perfectly straight? Well, it's close, except for it's also being pushed down, like that's pushing it down, right? That charge 1 is pushing it down a bit, so I would want to see it's being pushed away and, pushed away and a little bit down, kind of like that. Kind of bizarre. Just try a bit, right? It's being slightly pushed by that one. If I were doing this, I would modify this a little bit to make this push a little more. Don't like that. So from here, push a little more than the other line. Okay, this is an awkward one, right? And so here, I might draw something like this where it's pushed away and down like that. Kind of bizarre thing, right? It's getting pushed away and down like this. Maybe like this. Kind of weird. And then here it's really just like that. Might redo this one. This might just be pushed away, and here's getting sucked in, sucked in, sucked in. There will be a point here where this will go out, where it's being attracted, but eventually it just gets pushed away. So let's just work at getting this line perfect, maybe like that. I think it should be a little closer. It's getting kind of attracted by number 2, but eventually it's just too strong of a positive force, right? And we're not going to do measurements here, so I just want to see that there are moments I cannot see these lines cross, okay? Otherwise you'll lose a mark. I can't see lines cross, but then there will be kind of interactions where they'll kind of follow the same pattern. I don't think this is really nice, but it's not the worst. Now we got to make sure, don't know if it'll work that way, that these are all, this is double, they're all moving away. So we're going to add a lot of lines here. Let's see, that looks pretty good. So I want to highlight there's this weird area in the middle here where there needs to be this like imbalance where we're not sure what would happen to a charge here, where it would kind of be in limbo, where it's stuck between charge 1 and 3 and 2, where it's not quite sure where to go. But this is kind of what it should look like. So make sure you're following all 4 rules. Lines aren't crossing. They're always going from a positive to the negative, or else just away if there is no way for it to get. Like these ones here, there's no way for it to get to charge 2 because the repulsion from the other 2 would just stop it. Okay? And so it's got to move away. Any other one is going to try to get to number 1. Make sure that you've got twice as many lines on charge 1 as you do for charge 2 or 3. Like I've shown you, you don't really need to count too much. I just want to see that you put in some effort. In reflection, I should probably add a couple there, but that's probably good. And then make sure that, what else, other rules do we got? Lines never cross. Lines go from positive to negative. And that with a double we talked about. And that all of the lines are pointing in a direction that a positive charge would feel a force. That's it. Now you should work on practice questions, do a few of them, check the answers. 125, I'll be available for questions. If you have other questions, you can always email ahead of time. That's fine. And I'll probably be able to get to you. But I'm designating time from 125 on just for you guys. So that's when I'll be super available for you. All right, good luck.